Okay, so we're going to be graphing quadratic functions. So the first thing to review is standard form of a quadratic function. Y equals ax squared plus bx plus c. So get that copied, and what you'll notice is the format looks a lot like what the functions look like when we were factoring. We still have an a, b, and a c. Okay, so that should all be familiar. So this is the standard form of a quadratic function. Now, when you graph a quadratic function, it creates a shape that we call a parabola. So a parabola is a U-shaped graph of a quadratic function. So the parabola takes on a U shape. And it's, instead of, the capital U like I wrote here, it's more of a U like this. Or like this. Okay, sometimes they're, skinnier. Sometimes they're wider, but that's in general the way that your graph will look. Now, with parabolas, there are certain parts that have names, and we'll go through a bunch of vocabulary through this. But one of the very important pieces of a parabola is the axis of symmetry. Okay, so the axis of symmetry, let me move this up, is a line that passes through the graph in such a way that the half of the graph on one side of the line is a mirror image of the other half. So we're creating a symmetrical shape is what's happening. And the axis of symmetry is kind of like that mirror, or the line that creates the left side and the right side. Okay, so we're going to do an example, and you'll be able to see what I mean about the axis of symmetry and the shape, and we'll get some vocabulary down. Now, if you happen to have graph paper, you'll want to use that. If not, you'll want to make, whenever you see me graph something, you'll want to make sure that you create something on your paper that allows you to have an accurate graph. So the example that we're going to look at here is y equals x squared. And what we're going to do is we're just going to make a table of x's and y's. Now, there is a process that you will learn for how to graph these without a table, but we're going to start with a table. It's always good to know how to graph these with a table, because if you ever forget, the tricks, or you forget what different parts do to a function, you can always come back to a table. So we're going to start, if x is -3, y is 9. If x is -2, y would be 4. If x was -1, y would be 1, 0, 0. And we're going to continue down with +1, +2, +3. Okay. And what you'll notice is that as you look at my table, my numbers start large, get to 0, and then get large again. And you can also see that I have a 9 and a 9, a 4 and a 4, a 1 and a 1. So hopefully from that you can kind of see the symmetry that's going to happen. But let's go ahead and graph. So -3 and 9, -2 and 4, -1, 1, 0, 0. So you can even see from here that we're going to have symmetry, that we're going to have a U-shaped graph. Now, it's not a V. You don't want to make this like a straight line with a point. It does curves very slightly, but it does curve. Okay, so you want to make sure that you include that curve. Now, going back to the definition of axis of symmetry, the line that passes through the graph in such a way that the half of the graph on one side is a mirror image of the other half. And what you'll notice on your table is right here is where it starts to shift, right? 9, 4, 1, 0, 1, 4, 9. So we could say the 0, 0 is kind of like the mirror, right? Same thing on my graph. This right here would be my axis of symmetry. Okay, that's where this shape is cut in half and the left side and the right side are mirror images of each other. Now, the way that you would write the axis of symmetry is we identify it using the x coordinate of the vertex. Okay, the vertex is the point where the axis of symmetry begins. So, for example, on our table, since this is where my points start to mirror each other, 0, 0 would be my vertex. On the graph, this point here where my parabola is decreasing and then shifts to increasing, or the point where the axis of symmetry goes through, that is the vertex. Okay, so off to the side, we have axis of symmetry is going to be x equals 0. So that's how you write the axis of symmetry, x equals 0. And if you think about it, the line x equals 0 is actually this line. The equation of this line is x equals 0. It just so happens to also be the x coordinate. Okay. So this is the equation of the vertical line, but it's actually the same as the x coordinate of the vertex. Okay. There's something else that the graph shows us, and that's something called the minima. Okay, minima is the smallest output of the function. Okay, now output is a y coordinate or a y value. So they're asking for the y coordinate of the vertex. If you have a minima, then you also have a maxima. Okay, so in this case, our minima would be 0 because that's the lowest point, right? The smallest y coordinate. The maxima is going to be the highest output. Now, in this case of the parabola I have here, the highest output is going to be infinity, right? Because my parabola is going to go on forever. And you might think, well, they all would be infinity. Now, sometimes these parabolas point down. And when they point down, then it's going to be a little bit of a different story. And we can see that in a little bit. Okay. So again, if all else fails, if you don't have a graphing calculator, or you don't remember the next part that I'm about to show you, we can always graph with a table. Okay, so we're going to do an example, and we're going to graph with a table, and then we can start looking at some of the special things that happen with some of these equations. So we're going to graph the quadratic function using a table. Okay. So we've got 2x squared minus 8x plus 6. So we're going to make a table. And we're going to choose, I'm going to give you the x's to pick. 0, 1, 2, 3, and 4. And we're just going to substitute, right? So anywhere that I see is an x, I'm going to replace it with a 0. And I get 6. So go ahead and keep working on the table. And if you are working this along with me, you'll notice that we start having a mirror image here, right? Eight times 4 is not 36, sorry. All right, little mental math break there. Okay, so what you maybe started noticing, and I did too, is I have 6, 0, negative 2, 0. So now I'm starting to reflect, right? So that would mean my next would have to be 6. And the reason I know I can predict that is because my x's went in order. So I know if I start seeing that reflection. Okay, now on your own, when you create a table, it might not always work out so perfect because I knew which x's to pick. And there are ways to figure out kind of how to start with the table. But sometimes you're just going to have to kind of guess and check and hope that you picked some good x's. So what we notice is, because this is my reflection, I know that this point here is going to be my vertex. And I'm just making some mental notes just kind of based on what I've seen in the last little section. So now we're going to go ahead and graph. So hopefully you have some graph paper. And we're just going to start plotting our points. 0, 6, 1, 0, 2, -2, 3, 0, and 4, 6. And do your best to, oops, I missed that a little bit. Remember, it's a U shape, and I know it's sometimes the vertex makes it look like a V. So I'm just going to label, this is my vertex at 2, -2, right? My axis of symmetry, oops, sorry, it's not my axis of symmetry. Here's my axis of symmetry. Right? And I would call that x equals 2, because that's a vertical line going through x equals 2. Also my x-intercept, or excuse me, my x-coordinate. A couple other things that you're going to need to make sure that you are able to describe are the domain and the range. Okay, so let's talk about that. Remember, the domain are the x values. Possible x values, right? And the range are the possible y values. Okay, so my axis of symmetry was x equals 2. My vertex is 2, -2. My domain, my possible x values. So if I look here, right now, I have some x values plotted. We write our arrows at the end because we know that this could go on forever, right? I don't want to include in my domain just what I see in my graph. We have to include everything possible, right? All possible x values. So because my line is going on forever, even though this does look really tall and skinny and it feels like it would never really cover this area, it actually will eventually. It might take forever, but it eventually will. So we want to say all real numbers. Okay, and all real numbers includes negative infinity, to positive infinity. Okay, that's also an option. Another way you might see all real numbers eventually is an R, but instead of like the single line for the side, it's like a double line. Now in your assignment, all real numbers will be what you choose, but these are different ways to show all real numbers. Okay, so 3 different ways to express all real numbers. Now the range are the possible y values, and if we look at our graph, I can't have any y's down here below the vertex because my y values are above this vertex point. So my y values can include -2 here, and they can also include every other y above it. So my range is going to be when y is greater than or equal to -2. Okay, let's try one more example. Y equals, or excuse me, y minus 4x plus 2. Add a little y equals in front. Okay, so let's make our table. And let's take the same, start with the same numbers that we used on the last one and just kind of see what happens. Just going to go 0, 1, 2, 3 just to see if I kind of picked some right numbers. See if we can find where that vertex is. So I have 0 minus 4 times 0 plus 2. So go ahead and start working on the table with me. Okay. Let's see what happens on this last one. I feel like we're getting smaller and smaller and smaller. So maybe if this becomes 0, then I know, we start getting kind of bigger or something. I don't know. We'll see. Or And if you notice now, I've got a repeated output. So that tells me that, that this is my vertex. So I'm going to continue on. I'm going to do one more here. And because I know that this is my vertex, I can predict that my next point here, or my next output, is going to be a 2. Now, if you pick your numbers in the table and this doesn't happen as nicely as mine did, if you notice that, your second number here is your vertex, you will want to include some other x's in the other direction. When you're graphing these, they come out a lot nicer if you're using tables, if you have that mirror image. Okay. But I would say as long as you can figure out where the vertex is from your table, then you can always create that mirror image situation on your graph. Okay, so let's go ahead and graph this. So 0, 2, 1, negative 1, 2. We got lucky. The vertex is exactly the same as the other one. And now I know, even if I hadn't finished the table over here, I know that my next point would have to line up at y is 2 because I have to create a mirror image situation. Okay, so let's go ahead and draw that. We're going to identify the vertex, the axis of symmetry, the domain, and the range. Okay, so the vertex is 2, negative 2. Axis of symmetry is this line right here, right? It's what cuts my parabola in half, and it's actually the x-coordinate. My domain are all of the possible x values. So I don't have any x values not included. So I'm going to say all real numbers. My range are all of the y values that are possible. So my y values start at negative 2, and it's going to include every other y value. So y is greater than or equal to negative 2. Let me just kind of break up the color here so that you can see all the differences. That's it. That's how you would graph from a table. Next time we'll look at using the A, the B, and the C to create the graphs.